Looking at this, we are going to continue with graphing different types of functions. So we are going to graph cubic functions today. So a cubic function, looking at what that is, the largest exponent is going to be an x to the third. So it's going to have that 3 as your exponent, and that's what makes it a cubic function. So we are going to base everything that we're doing today off of that parent function. So when we look at this, remember the parent function is your most basic type of graph that you can have. And looking at our parent function for a cubic, it's just going to be that y equals x to the third. Okay? And again, like we've done already with the square root functions, we are going to graph this and we're going to see how those transformations change it, but we're going to graph it based off of that parent function. So when I look at a parent function, I'm going to create my table. And a cubic function is going to be a little bit different than what we've done. So it is going to have a curve to it, but not as much as a parabola. Okay, so looking at this, we're going to graph and we're going to pick some negatives and some positives. Okay, so when I look at these x values, if I were to plug them in right here, so if I do -2 to the third power, remember that means -2 times -2 times a -2. And if you don't know, in your calculator, you do have that exponent key. So looking at this, if I want to do -2, remember I'm going to put it in parentheses, raised to that third power. Remember, this is your exponent key right here. So I'm going to hit that, and then I can get that 3 as an exponent. And that's going to give me a -8. Okay, so I plugged in a -2 and I got -8. I'm going to do the same thing for all of these. So if I plug in a -1, -1 to the third power just gives me a -1. 0 to the third power is pretty easy because that just gives me 0. And then what we're going to notice is it does kind of start to repeat a little bit, but if I turn in a +1, 1 to the third power is going to be a +1. And then 2 to the third power gives me that +8. So it's almost like they repeat, except for these are negatives and these are positives. So what that graph is going to look like, we're going to graph these. So I'm going to go over to -2 and down to -8. Over -1, down 1. 0, 0, 1, 1, and then 2 and a +8, which would be right there. So looking at this, it looks a little bit weird. This is going to be the main part right here. This is going to be where this graph kind of curves. So we're going to have it going straight, curve right there, and going back down. So that's what a cubic function is going to look like. These important parts in the middle right here, it's going to look like it's a linear because it's going to look like a straight line, but that's actually the start where it starts to curve. So looking at that, the important part right here, that 0, 0 right in the middle, looking at that, that's going to be called our turning point. So we've already done square root functions where we called it the starting point because that was the start of the graph. Here, we're looking for that turning point. That's the one point in the middle where it starts to curve for that graph. So looking at this, just a quick reminder, no matter what type of graph we look at, we should be able to find the domain and range of those. So if I'm looking at this parent function, that domain, remember, from left to right, it's going to continue to go. So that's your negative to positive infinity. And then your range being the same thing because it's going to continue to go down, it continues to goes up. So that would be your negative to positive infinity as well. Okay, so we're going to look at this concept today. We are going to graph these cubic functions and we're going to base everything off of this table because this is the parent function. So we are going to be looking at these numbers right here. So we're going to be changing that turning point, but these numbers, the negatives and those positives, that's going to kind of give us the direction as far as where we need to go. This is going to be very similar to what we've done with other graphs. So when I'm looking at transformations from that parent function, don't forget your a value is your vertical stretch or shrink. So that's similar to what we've already done. Remember, if your a value is greater than 1, that's your stretch. If your a value is less than 1, that's your shrink. And then also if it's that negative a value, it's going to be reflected over that x-axis. So this is the same for quadratics, for absolute value, and for those square root functions that we've already done. Okay, remember the number inside right here, that h value. If it is a negative, that means it's moving to the right. And if it's a positive, it's moving to the left. Because remember, it's always going to be that x minus whatever that h value is right there. And then your last one, the k value, remember that just moves it up or it moves it down. So again, we've already done this before, so this should look very familiar. Like right here, that turning point, that's what we're looking for. That's going to be your H and K for your equation. So that turning point, you get straight from your equation. That's the part of your graph where that graph starts to curve, and it's going to be right here in your equation for the H and the K. Okay, so for these examples, we are going to identify the different transformations, and then we're going to use those transformations to graph these cubic functions. All right, so if I look at the first one, I have a +2 right here. So that +2, I don't have any parentheses, so that tells me that that is moving up 2 units. So this graph has moved up 2 units. So what we're going to do is we are going to identify the turning point, because that's kind of like the most important part that we need to find. So if I look at my equation, again, I don't have parentheses, so I'm going to start with a 0, and then that y value is going to be 2. So that would be my turning point. So I'm going to go ahead and graph that. And I know this is the middle of my graph, 0, 2. So remember I said we're going to use these other numbers in the table to help us graph it. So I am going to rewrite it down here just so we can see it on the screen. And this is very similar to what we did with the square root functions. So remember that turning point falls in the middle, and we've already found our turning point at 0, 2. So now we're going to use these other points right here to tell us the direction to graph. So from that turning point, I'm going to go over 2 and down 8. And that's a point. I'm going to go over 1 and down 1. I'm going to go over to the right 1 and up 1. And then over 2 and up 8. So realize all of that just came from that turning point. So when I graph it, remember right there, it's going to start to curve. You're going to notice those 3 points right there together. That's where your graph starts to curve. So everything that we are using from this table is telling me the direction that I need to go from that turning point. All right, so if I look at the next one, I have a number inside the parentheses. It's a +1, so that tells me it is going to the left 1 unit. So this entire graph is going to the left 1 unit. So we need to figure out where we're starting with that turning point. So my turning point, remember, it's whatever's inside your parentheses. So that's going to be a -1. And then I'm not adding or subtracting anything, so that would be 0. So I'm starting at -1, 0. And then again, I'm using these points to have my direction for my other points. So I'm going to go over to -2 and down 8. I'm going to go over 1, down 1. And then this one is going over to the right, up 1. And then over 2 and up 8. And if I connect those, remember those 3 in the middle is where I want that graph to curve. Okay, so again, I have those 3 in the middle. That's where it curves. From that turning point is where you're graphing these. It's giving you the direction. All right, so let's look at the next one. We're going to kind of merge this. So now I have 2 numbers. So looking at this, the 3 on the inside tells me that it's going to the left 3 units. And then this is going down 2 units. So the turning point, I need to put those numbers in an ordered pair. So remember, this is a -3 and that's a -2. So that's my turning point, the middle of my graph. So I'm going to go over to -3 and down 2. Okay, now from here, remember I'm doing my direction. So this tells me from that turning point, I'm going to go over to the 2 here for the -2 and down 8. So it's going to be right there. I'm going to go over to the -1 and down 1, over +1, up 1, and then over 2 and up 8. So again, make that little curve when you connect those 3 in the middle. All right, so looking at these, our turning point is where we started because everything was based off of that turning point, and make sure that we can talk about whether it's going left or right, up and down. So now looking at these next ones, now we're throwing in those a values. So now my a value has changed. So as soon as I see that my equation starts with a negative, I know that it's reflected over the x-axis. And then just the 2 right here tells me that it is a vertical stretch by a factor of 2. Okay, I don't have anything changing as far as going left or right, up or down, which means when I look at this one, my turning point, is at 0, 0. So very similar to the parent function. So I am starting at 0, 0. But because of this 2 right here, that vertical stretch, that a value, very similar to the square root method when we're looking at those functions, right here, if I have an a value, you need to take that a value and multiply it by your y's. So that's how it's going to change your graph. Whenever you have an a value, you multiply it by your y's. So if I'm looking at my table, and I'm going to write a really skinny one right here, okay, I'm still using these. So -2, -1, 1, 2. But here, I'm going to multiply each one of those by a -2, my a value. So this is going to become a positive 16. This becomes a positive 2. This becomes a -2, and that becomes a -16. Now, the 16s are going to be kind of hard to graph, so we're just going to graph the ones that are in the middle that we can see. So remember, this is starting at the turning point. So the -2, 16 is going to go off the graph, so I'm going to go over to -1 and then up 2, and then over to +1 and down 2. Okay, the 2, 16 and 2, -16 is going to be all the way down here somewhere, so we're just going to connect them right there so we can see that curve. And remember, that negative is that reflection. That's why this one is going in a different direction than those other 3. Okay, so if you have an a value, you just take it and multiply it by your y's to get your new y values. So let's look at this one. So this one, again, is going to be a vertical stretch of 2. And here we have a number in this inside, so that is going to go to the right 1 unit. And then this is going to go down 4 units. Okay, so that's the direction that we're going. Turning point, we need to go ahead and label that. So that turning point is going to be a +1 and -4. So I am going to go ahead and graph that one. So I know that's the middle of my graph. Okay, again, I have this a value. So I'm going to multiply them by 2. So realize it's going to be the same thing here. It's just here I don't have to worry about the negative. So it's -2, -1, 1, 2. So right there that would be a -16, -2, 2, and 16. Okay, so this one I'm multiplying just by a 2, not a -2. So I would multiply all those by a +2. And that's where I got this new table. So from my turning point, again, the 16 is going to be kind of hard, so let's just graph the other one. So I'm going to go to the left 1 and down 2, and then over to the right 1 and up 2. Whoops, paper moved a little bit. So there is my graph. Okay, so again, a value, multiply it by those y values. So looking at this last one on the front page, again, we have that negative a value, so that one is going to be reflected over the x-axis. The 1/2 is going to be a vertical shrink by a 1/2. So remember, if I see a fraction there, that's a vertical shrink. And then the 2 in the middle right there, that means it's going to the right 2 units. So now looking at that and using that, oops, my turning point is just a +2, 0, because I'm not adding or subtracting anything on the outside. So I'm going to go start there. So that's the 2, 0. And now remember, I have an a value of a -1/2. So I am going to create my new table by multiplying all those original y values by a -1/2. So if I do -8 times a -1/2, looking at that, that's going to give me a +4. And then -1 times a -1/2 is a +1/2. And then 1 times the -1/2 is -1/2. 2 times the -1/2 is going to give me, whoops, what did I do right here? Oh, so 2 times the -1/2, remember I thought I was multiplying by 2. So times the -1/2 is going to give me a -1. Right there, that should be a +1. So -8 times 1/2. That's what I'm doing. Sorry. Okay, I was getting my x's and y's confused. So I am multiplying these by -1/2. So that does give me a -4. That's going to give me a +4. So I had it right the first time. Actually, positive, negative. I'm struggling today. Okay, so I multiplied all my y values by that -1/2. Okay, so from here, I'm going to go over 2 to the left and then up 4. Because remember, this is a reflection, so it is going to be going in the opposite direction. Okay, and then I'm going over to -1 and then up a half, so that's going to be about right there. We're going to kind of estimate. Over 1, down a half, and then over 2 and down 4. Okay, so again, I have those 3 in the middle. Remember, that's always where your graph starts to curve. So this one, I struggled a little bit. So just remember, I'm taking that original table and I'm multiplying those y values by a -1/2. And that's how we got that reflected graph. Okay? All right, last part of this is just writing equations. And again, we've done this before with other graphs. So how to write the cubic function equation. So looking at this, remember it's supposed to be y equals a x minus h to the third plus k. So they're going to give you a turning point. That's what gets plugged in here and here. So I plug in my turning point right there. And then the ordered pair they give you is your x and your y. So that's where you're plugging in your point. So what you're doing is you are solving for a. So you're going to plug in all the information they give you, those 4 numbers, into this equation. You're going to solve for a, and that'll give you enough information to write your equation. Okay? So I would go ahead and label this. This is h and k. That's x and y. So looking at that, if I'm plugging this in, this is y equals, so my y value is 12, equals a, I don't know. That's what I'm always going to look for. And then x minus h. So that would be 1 minus a -1 cubed, and then plus my k value, which is a -4. Okay, so plug everything in to this formula, and then you're going to start simplifying. Remember that double negative is going to turn to a positive. So that gives you 2 on the inside. And then 2 to the third, remember that means 2 times 2 times 2 is going to give you 8. So now I'm left with just a regular 2-step equation to solve. I'm going to add 4 over there, which gives me 16, and then divide by 8, so your a value is 2. So that's my a value. Again, make sure I go back and write my equation. I want my equation to look like this. You are plugging in your a value and your turning point. That's the only numbers that you should have in there. So that would be 2, and then x, and that's going to be a +1 cubed minus 4. So that would be my cubic equation. Okay, so just make sure, plug in everything you know, simplify it, you're solving for a, and then always make sure you go back and write your equation. All right, so looking at the next one, I have h and k, x and y. So I'm going to plug all that in. So I'm going to start with my y equals a, I don't know. Your x is -2 minus your h, and then plus that k value. So now simplifying this, -2 minus 0 is -2. And then if I do -2 to the third, that means -2 times -2 times -2 gives me a -8. So that's my regular 2-step equation that I'm going to solve. So I'm going to add 5 over there, which is going to give me a -2. And then I'm going to divide by -8. So just be careful right here. When I do -2 divided by -8, that gives me a +1/4. So I do get a fraction for that a value. That's fine. You're just now going to take that and plug it into your formula. So it would be y equals the 1/4, and then x minus your h value cubed, and then that -5. So this is an option. Realize x minus 0 would just cancel out, so you're just left with an x cubed. So these two equations would be the same thing. Okay, so writing equations, you're just plugging everything that you know into this set formula. You're solving for a. Make sure we understand how to use these transformations. Remember, this is the important table for cubic functions, and everything is going to be based off of that table.